Hello, and welcome to the second part of our two-part workshop on harmonizing data on child well-being. This is part of the Coordinate project. My name is Scott Milligan. I'm a researcher at GASIS. I'm just going to go ahead at this point and start sharing my screen. In today's workshop, we'll look at a specific example of how to conduct harmonization by taking a simplified research question and discuss the technical aspects of the harmonization process. By the end of this workshop, we hope that you'll be able to take your own child well-being variables from different data sources and harmonize them together to help you examine research questions in new ways. The specific example that we'll look at today revolves around a simple research question, namely, what is the impact of bullying on children's happiness? We'll be mainly concentrating on the technical aspects of the harmonization process today. So the harmonization that we will be working on today is drawn from the Harmonization Toolbox that was introduced in the previous workshop. The toolbox can be accessed through this link, which is also included in the comments to this video. The instructions for installing R, the software that we'll be using to do the harmonization, can be found on the R project website, as well as in the Harmonization Toolbox. The commentary that we leave on the code, which is also available following the links attached to this video, we hope this commentary will help to provide users to generalize this code into other statistical software packages. The other requirements that are not strictly necessary have been used in this workshop, including the use of the here package, for example, which we will discuss later, are explained on the Harmonization Toolbox website. All of this will be discussed in more detail on an upcoming slide. I'd like to start also by discussing the wider context of this workshop, what the Coordinate project is, and what its objectives are. As we discussed in the previous workshop, Coordinate stands for the Cohort Community Research and Development Infrastructure Network for Access throughout Europe. The project received funding from the European Union's Horizon 2020 Research and Innovation Program, and it brings together 22 partners from 14 countries who will initiate a community of researchers and organizations that will drive for the coordinated development of comparative birth cohort panel survey research in Europe. The aim of the workshops is to provide a demonstration on harmonization in the context of child well-being research. Over the two workshops, we have introduced the concepts of child well-being by highlighting the debates around its definition and measurement, and discussed the importance of harmonization in the context of child well-being research and policy. We introduced the concept of harmonization, including the different types of it, in the previous workshop, and also discussed the harmonization strategies and how they are applied. We also will or have presented a comprehensive child well-being research database that we hope users can use to learn more about where they can access child well-being data and how to use that data. And today we'll cover the technical aspects of harmonizing a child well-being variable, as well as taking a look at the Harmonization Toolbox introduced in the first workshop. So I first want to show what the toolbox looks like. This is the landing page. When you follow the link from the earlier slide, you should arrive here. You'll see there's a brief introduction and a discussion of what harmonization is and how we use it. These concepts, as I mentioned, were discussed in the first workshop. This landing page basically paints a picture of how we think about harmonization and about the general workflow that we use in the harmonization process. We've included a number of key variables, and so if you click through to the specific variables being harmonized, you'll see the following. The top of the page guides researchers through the setup of the harmonization process. Since we're using bullying as the main variable harmonized in today's workshop, I've brought up here the bullying page on in the Harmonization Toolbox. This briefly outlines what is involved with harmonizing with our understanding of what bullying is and how it's related to child well-being. There's also a link to the database to find more information about available related data sets as well as the metadata on the top of this page. Then you'll see below a discussion of the setup that's necessary to harmonize this specific variable. It varies between the different variables, so each of the harmonization pages is slightly different. After the setup, the next stage is the data importation. Here you can see how we've imported data from different sources, mostly data sets that are stored in SPSS or Stata format, and what we've done to import the necessary variables for the harmonization. Specifically here are the bullying variables as well as other identifiers that we will use later to match the data back to the original data source. Underneath this, we prepare the variables for the harmonization process. First, we provide a function to extract the necessary data that we will use to examine the variables and make the harmonization decisions. And as we'll discuss later, we'll also write a codebook of sorts containing the variable and the value information from each of the variables for the harmonization process, essentially setting up the variables to be harmonized. And then below this, the user will be guided to create a crosswalk table, which we'll discuss later. Is one of the intermediate steps in the harmonization process. And this again requires an R function, which is shown here and we'll discuss later in an upcoming slide. Then finally are the instructions for the actual harmonization itself. Specifically here, we use the linear stretch method, which was discussed in the first workshop. We have also included the instructions for the production of the data at the end, which includes saving it as an R dataset or other formats, such as SPSS and Stata. So the data that we'll be using today to illustrate how to use the Harmonization Toolbox to harmonize a variable comes from 5 simulated data sets. We'll harmonize measures for bullying, which these measures for the main predictor variable are derived from actual survey items, even though the data itself is then simulated. So the question text is from actual bullying survey items. Other variables for the research question will be assumed to have been already harmonized or not in need of harmonization. And the data and analysis that we present in this workshop are not weighted. This is an important point here that I'd like to mention. The decision of whether or not to use weights in data harmonization is an important one because it can significantly impact the accuracy and comparability of harmonized data sets. When using weights, this can help to create or to account for differences between sampling methods or enhance comparability and improve statistical accuracy. But the weights can also add unnecessary complexity and sources of error to the process, leading to unreliable results. For instance, if the weighting methods differ between surveys and survey designs, it won't be possible to harmonize the weights effectively. We've opted not to use weighting in the Harmonization Toolbox due to the heterogeneity of the survey designs that are included in the data that we use. And as a general note, researchers should consider the nature of their data, the intended use of the harmonized data set, and the available resources before deciding to incorporate weights. Careful consideration of these factors can help ensure that the harmonization process produces a reliable and accurate data set that meets the research objectives. So the data and code that are used in this workshop are available by following the links under this video. You can pause the video now to download them. So I'd like to now discuss a bit about the data that we will use here. The focus of the research question again is on how being a victim of bullying affects the self-reported happiness of children. As I said above, the data are from 5 simulated data sets, but using the actual wording of real survey response items. The dependent variable that we will be looking at is the self-reported happiness of children. And in these data sets, it ranges from 1 being very unhappy to 6 being very happy, as a kind of Likert scale variable. The main predictor variable that we will focus on is children's experiences with bullying, and the main control variables that we will briefly address, but not look at in too much detail, are the count of positive relationships children have in their lives, their biological sex, their age, and the country of residence. The analysis will be focused on the harmonization of the bullying variable, but we also want to illustrate how that would look in a harmonized data set. We'll assume that the other variables, aside from bullying, have already been harmonized or don't need to be. So, I'd like to talk about the specific bullying features that we've used from the different surveys, from the different data sets. So from the first data set, the question text was, how often do you experience bullying? And the response categories were never, rarely, sometimes, and often. The second data set's question text was, how often are you a victim of bullying? And the response categories were never, occasionally, and daily. The third data set is, or asks children if they have been a victim of bullying in the past, with yes and no being the 2 response categories. The fourth data set again asks about the frequency that children experience bullying, specifically the frequency that bullying negatively impacts their lives. And the response categories are always, often, sometimes, rarely, and never. And then last, the fifth data set is a scale from 1 to 10. It's measured on a scale from 1 to 10, where 1 is never and 10 is constantly. How often has the child experienced bullying? So I'd now like to talk about the setup of R before we begin the actual harmonization and analysis. If you haven't already, you can start by setting up an R project on your computer. R projects are a way of organizing data, code, the production of reports and other graphics on your computer. There's here, if you follow this link, you can get a little bit more information about how to set up and work with our studio projects or projects within RStudio. We use the here package to organize and reference files. It's a handy way of simplifying file referencing and referencing files within your project folders. For instance, when we read in the data, which will be in the next or an upcoming slide, we will use the read sav function to read in SPSS data, and then we say here and indicate where the data are saved within the project file. So in this case, the data folder, and then the name of the file. The minimum folder setup to do the harmonization that we are doing today should include the following folders: simply a data folder and a codebook folder. I have set up the codebook folder within the data folder since I think of it as a subset of the data sets, but it doesn't necessarily need to be that way. It might be useful to create other folders, such as the code folder for code and the analysis code, for instance, a folder for the graphics that are produced, and a folder for reports that are produced. The next step in the setup is to load the necessary packages. Here are the packages that we use to do the various stages of harmonization. So the Haven package is used to import foreign statistical formats such as SPSS. The labeled package helps to work with variable labels, value labels, and also missing values. The tidyverse package is a range of packages or a suite of packages that are useful for data management. The question R package helps with frequency tables. The write Excel package is useful for exporting files to a spreadsheet, such as Excel. Similarly, the read Excel package imports from Excel and other spreadsheet formats. The here package, as we already mentioned, is useful for efficient file referencing, and the plotrix package helps to rescale the variables in the harmonization. If these necessary packages have not already been installed on your computer, you can download them directly within R or RStudio using a function like the install packages function to download one or more packages. The next thing is to load the data into R, which is a straightforward process. Since the data is already stored in SPSS format, we can use the read SAV function, which I mentioned earlier from the Haven package, and we use the here package to specifically point to the place where the data are stored. And again, we hope that you are able to follow along with us using the code that is accessed, that is linked below this video, as well as the data that are also available. In this case, as I've mentioned, the data are stored in a data folder within the project files, which was set up in advance as we discussed. DF in this case stands for data frame, and so I've named the different data sets data frame 1 through to 5. This can be anything though. It doesn't need to be such a nameless function. It could also be the name of the actual data survey. And the next thing that we can do is examine the data, which is the first step that most researchers are most likely familiar with. So here I have the univariate distribution of each of the bullying measures from the data sets. And we can see that the distribution of each univariate data variable in the from bullying. One thing that we want to check is the direction of the measurement. It should be the same in all cases. So for instance, that low values are associated with less bullying and high values with more bullying, or vice versa. And this can be done after considering the variable in more detail also. One thing that we can notice here is that the direction of all the variables is the same except for in the fourth data set, where it looks like higher values are associated with less bullying. We also notice that the third data set only has 2 response categories, and we will come back to these points momentarily. So in examining the data, we can already make the first harmonization decision, which is to not include the data from the third data frame. The question text as well as the data are difficult to incorporate. If we recall, the question text was, I have been a victim of bullying in the past, with the 2 response categories being yes and no. If we remember back to an earlier slide, all of the other variables have to do with the frequency of bullying, how often children are victims of bullying, or how often it negatively impacts their life. So here we would make the decision, or I, as a researcher, would make the decision not to include this data in this data set. The concept is a little bit different and therefore not in line with the other variables. So moving forward, we would not see this data set again. We can also look at some of the cross-national comparisons that are possible to see if we notice any interesting features of the data in the cross-national comparisons. Here there are 2 data sets that have a cross-national feature. In data set 2, we see that there are 6 countries: the Czech Republic, Germany, Spain, France, the Netherlands, and the UK. And in this case, it looks like for the most part, the distribution at the country level is similar to the overall univariate distribution of bullying, namely that Most children have not been a victim of bullying. Some occasionally are a victim of bullying, and then there are the least amount that are daily victims of bullying. And similar in the fourth data set here, we have three countries: Austria, Switzerland, and Germany. And again, we see that that for the most part, the univariate distribution is similar to the country level distribution. We can also see here how the values are increasing as bullying goes down, which is the reverse of the other variables. So always is coded as a 1, often as 2, sometimes 3, rarely 4, and never 5, meaning that never being a victim of bullying is a high value, whereas in the other data sets, high values are associated with lower levels of bullying. We can also look at the model estimates for children's happiness using the predictor variable of bullying as well as the other control variables which we mentioned. Here we have a table addressing the research question for each of the data frames. Already data frame 3 has been removed from the analysis. As we can see here, each data frame has its own column in the table. Looking at the different predictors of children's happiness, we can see with specific reference to bullying that in data frames 1, 2, and 5, as we would expect, the greater frequency of bullying that a child experiences, the less happy that they report being. In the fourth data set, where lower levels are associated with higher levels of bullying, lower values are associated with higher levels of bullying, the bullying coefficient is positive, meaning that at less frequent levels of bullying, happiness is higher. This, of course, is what we would expect and in line with our hypothesis, but suggests that we need to recode the direction of this variable at some stage. The control variables are also listed here, but of less importance to us. And then we'll return to this table later at the end of the harmonization to see what influence the harmonization has had on the research question conclusions, if any. So the next step that we would do is produce our own codebooks, sort of on the fly, using the value coding from the original variables that we have imported from other sources. This here is a function that helps us do that. I won't go into too much detail about this function. Again, it's available on the code that is linked below. But it's also available in the Harmonization Toolbox, which we linked earlier and which is available. Essentially what happens to this code is that it creates this function called create codebook that strips the following information from the original data sets. It first takes the value of the response categories, the different values of the response categories, the value labels of each response category, and then it calculates the response frequencies within each category, so how many people reported each response value. And this information will eventually be stored in a spreadsheet, which we'll look at later, and then it should all become a little bit more clear. So to produce the codebook, we first take the info that we want, in this case the bullying variable, but of course it could be any variable that you're interested in. And we use the function that we created in the last slide to get this information. So there's basically 2 steps for each data set. We first produce a little codebook with the following information. In this case, that's being extracted from the first data frame here in this short snippet of code. It takes the name of the variable, the variable label, and the value of the frequencies. And then it extracts that from the first data frame. As I mentioned on the previous slide, it takes the name of the variable label, the value frequencies, and then also adds the name of the data set. So this can be repeated for the rest of the data sets. Notice that we go from data frame 1 and then here to 2, skipping 3, and then go to 4 and 5. And then what we have now is all the information we need that we want to combine and export to a spreadsheet. and it operates like a kind of code book for each of the data frames in on our target variable, which, as we know, is bullying. So now we write this code book into an Excel spreadsheet and save it in the codebook folder, which is under the data set, and then we can move on and examine that. So this is what it would look like, the spreadsheet, if you look at, if you open it from your codebook folder. We have the variable name bullying on the far left column, which is here listed as column A, and then the variable label, which in each case was bullying, with a small b. This is followed by the labeled formats and the value frequencies. So as we discussed earlier, the first data frame has bullying measured as a 4-category response, and we see here those response categories as well as the frequency within each category. So people reported as never being a victim of bullying, which in this case there are 245 respondents or children who reported never experiencing bullying, followed by response category 2, or rarely being a victim of bullying. There are 112 of these children in this case. Then category 3, sometimes being a victim of bullying, which there are 62. And finally, the last category, children who are often victims of bullying, there are 31 of them. So each row in the spreadsheet has a different data set. Then in this case, row 3 is from the second data set, and so on through the data sets that we have. Something else that we should note here that we've already discussed above is with respect to the fourth data frame. The question was about the frequency that bullying has negatively impacted the children's lives, where low values were associated with more bullying in comparison to the other variables where low values are associated with less bullying. And so this is something to keep in mind that we would want to recode fairly soon before we do any real harmonization work. So to reverse the direction of the response categories, we can use a process that probably most people are familiar with. First, we'll look at the frequency table before we recode. So for example, we have 106 respondents in category 1 from this fourth data frame, 170 in category 2, 93 in category 3, 313 in category 4, and 268 in category 5. We want to reverse this so that low values are high and high values are low. And so because there are 5 response categories, we simply subtract 6, or 5 plus 1, from each category in the bullying item from this data frame, which we see here in the mutate code in the middle of this slide, this code snippet here, where it says mutate bullying equals 6 minus bullying. And we copy the labels over so that we can see them later on, and then rerun the frequency table so that we can verify that the recoding was done correctly, which we can see it was. There, for instance, the 106 people that reported or that answered in response category 1 are now the 106 in response category 5, and vice versa. And then we're ready to create a crosswalk table using the reversed variable from DF4 as well as the other bullying variables from the data frames. What a crosswalk tables do is they help users or researchers show how equivalent elements in each survey can be remapped to a new schema, a new coding schema, in one new coding schema. It shows where to put the data from one coding scheme and mapping it onto the new coding scheme. So again, we need another function. This is very similar to the create codebook function that we used before, but now we have a create crosswalk table function. This function allows us to create a crosswalk table similar to the earlier code. So we won't spend tons of time talking about this, but just look at how it can be used. So from here we need to provide a loop function. We use this function looped over the data sets to take the proportion of each response category and split it into a longer table format where each response category has its own row in the table. And then we bind them all together and write that into a spreadsheet file. Again, I think it's worth repeating that all of this code can be found in the Data Harmonization Toolbox webpage, as well as linked below this video. And we'll see what the crosswalk table then looks like on the next slide. So the crosswalk table shows each individual value from each survey. It's a kind of a more manual method than the one that we will use when we look at the linear stretch. Again, on the far left, we have the survey wave name, and since there are four response categories in the first data frame, it has 4 rows. And similarly, there are 10 response categories for the fifth data set, and it has 10 rows accordingly. So the crosswalk table shows each individual response value from each separate survey file, and rather than being all in one cell, each of the response categories are now their own row. We have then the code from each of the response categories, and finally a target variable column, which we would use if we were using this method to map the new schema. So what we would do is map on a new value into that cell. Here the cell is in column F, named target value. And so, for instance, if the new coding in the first data set, people were coded as 1, or continue to be coded as 1 in the harmonized variable, then we would just simply write a 1 in the target variable cell. If people who were then children who reported being victims of bullying, as we see here, there are 31 of them in the first data set here, often being victims of bullying. Then they would be coded as, say, 10. That would get a value of 10 in the target value. We can also see here that the values from the fourth data set are using the corrected values. That's important to verify. So here, the fourth data frame from rows 9 through to 13 have the recoded values, or the reversed values, let's say. This target value then becomes the new harmonized variable, or would become the new harmonized variable. And so, as I said, a manual method that's often used and is quite popular, and it can be it's an efficient way to map original value codes to target values. But as we mentioned in the first workshop, and as I've mentioned earlier, we will be using the linear stretch method, which I'll demonstrate in the next slide in a little bit more of an automated way. As we explained in the previous workshop, the linear stretch method is a method in which the response categories are stretched to a larger scale range. So the lowest response option is assigned to the lowest value of the target scale and the highest to the highest value, and the intermediate options are given equally distanced values in between this range. In our linear stretch, we chose an 11-point scale, so from 0 to 10. This is primarily due to the bullying variable in the fifth data frame, which had also 10 response categories or response outcomes. But of course, other ranges are possible as long as the target outcome is greater than all of the input or original response categories. And then all we have left to do is the data harmonization itself. The code to scale variables to a specified range is rather straightforward. Here we have the first line, which produces a data set called survey files. This contains both the original unharmonized variable for bullying as well as the other items from the surveys. And then the following lines of code scale the variables to that specified range. First, we need to account for any missing variables, which are not actually an issue here in the simulated data, but I'm including nonetheless for people to be able to use in their own research, where they will most likely come across missing variables, missing values. Here what I've done is just removed any negative value as missing, which is a common feature of data. Then we will group the data by the different surveys. So that's the line that says group by, and then in parentheses survey. And then the values of each bullying variable are rescaled from 0 to 10 in the next line, and this produces a harmonized bullying variable, which we call here bullying underscore harm, and that's added to the combined data set, which we had called survey files earlier. This now contains both the original unharmonized variable as well as the newly harmonized variable, which the newly scaled to in a linear stretch method to 0 to 10. And then also the other variables and control variables and case IDs, country, and so on. We'll look at what that looks like in a moment. Then the last step here provides a variable label for the harmonized variable so that there can be no confusion about which variable is harmonized and which is the original data before the harmonization occurred. So here's what the harmonized data set looks like. Using the view survey files function in the RStudio, we look at the data viewer. Here we only see the first part of the data frame, but you should know that it goes all the way down to the bottom, to the end of the cases. And we see here from left to right what the data looks like. First, we have the survey ID, so in this case, DF1 through to DF5, as well as the individual ID. This is important because, so if in this case, if it's a child's individual ID, it can be important for users to link back to a different data set that might have context data, for example, or input from other family members or teachers or other possibilities. And then we have the other variables in the data set: age, the biological sex of the child, the socioeconomic status, the positive relationship count, the happiness, the country that they're resident of, and then the unharmonized variable and the harmonized bullying variable on the far right-hand columns. So at this point, the data is now ready to be saved and is available for further analysis. So if we want to save it for later use, we can use the save RDS function to save it as a R data set. As we called it, the survey files, we save that survey file into the data folder that we have set up. But of course, we can export it to other formats quite easily using the write SAV or write DTA commands to export the survey file data to SPSS and Stata respectively. And then we would want to probably examine the output. So here we've seen this earlier, this graphic before, with the main difference coming from DF4, which is now scaled in the appropriate direction, as well as the harmonized variable. The highest proportion of this variable has a count of children here who have not experienced bullying, and that is stretched out to 10, where there is a small uptick in children who have experienced bullying. So yeah, there's a skew towards children not having been a victim of bullying, with this small uptick at the end of the harmonized scale. We can also re-examine the model estimates for children's happiness. Here we have no real changes in the first 4 columns of coefficients, with the difference that the bullying variable in the 4th data frame is now a negative coefficient in line with the direction of the scale that we have recoded. And then we can also see in the harmonized data set on the far right-hand column that bullying has a significant and negative effect on children's happiness, which is in line with our hypothesis. So that's the main idea and the main approach that we've taken in constructing and building the harmonization toolbox, and to applying the linear stretch method to harmonizing child well-being variables and to harmonizing data in general. Before finishing, I'd just like to highlight a few things to watch out for and then make a few conclusions. First, when harmonizing historical data, which we do a lot in the Harmonization Toolbox, or the so-called legacy data, researchers should be careful to consider that there are potential biases or limitations of the original data collection methods. So in the context in which these data were collected, users should consider very carefully reading through the documentation that was produced with the original data, and also the question text to be analyzed carefully, so that there is an understanding of the context in which the data were produced. This is especially the case with children's data, and when children are being surveyed about things that pertain to their well-being. The quality and completeness of existing data sets should also be thoroughly assessed before doing any kind of harmonization of children's well-being data or variables. And researchers, of course, should be transparent about the harmonization process and the data that they produce when they harmonize variables, and document any kind of adjustments that were made to the original data so that they can ensure replicability and trust in the resulting data sets, as well as analysis. And finally, overall, we'd like to argue that ex post facto data harmonization is a powerful tool for social scientists, particularly when dealing with child well-being data. It can play an important role in overcoming limitations or enriching our understanding of children's lives and what affects their well-being specifically. And we think that by harmonizing existing datasets or legacy datasets, researchers can leverage valuable information from past surveys to inform current and future research questions, as well as survey methods and design. We also believe that this kind of harmonization allows researchers to track changes in child well-being over time, and allows researchers to identify trends and potential long-term impacts of social policies or interventions that have taken place. It also helps us to explore child well-being data across different geographical regions and historical periods, which gives important insights into how factors like culture or economic conditions, among other things, have influenced children's lives. In our view, it allows us to give new life to existing data and unlock the potential to inform current research and help improve the future research and data collection with respect to children's well-being. So, thanks for your participation and for listening. If you have any questions, please don't hesitate to contact us. Thank you.